It's upgraded 6 times. For us, we don't have this luxury. The space shuttle will terminate soon. And we have tested the detector on each component level, on detector level, in accelerators, and in thermal vacuum conditions. And then we test the whole thing at CERN with different beams. And we have most of the major electronics, 400% redundancy. Hopefully, we do not need any upgrades. There's no way to upgrade it. We have checked the magnet. The magnet first was used in '98, and recently in Aachen, we measured again, and the magnetic field still have not changed within 1% over 12 years. The consumables we have can last, we have measured it, and last more than 30 years. Without a shuttle, you are not going to think of an upgrade.
Go ahead.
Jim Siegel, Celebration Independent Newspaper again. Professor Ting, at what point after launch does AMS start operating? Do the crew members actuate it to begin that process? And do the crew members on the ISS have anything to do with collecting or analyzing the data or sending it back to Earth, or is it all automatic, or what?
First of all, on the fourth day, we will be moved from the shuttle bay to the station, and then we will be connected to the station. And then within a few hours, we should be able to get our events. And this is such a complicated detector. And we do not think it's a good idea to waste the astronauts' time. Because you really have to be 100% dedicated to such experiment. So we have not dared to bother them.
So it will happen by itself. You will turn it on from...
Yeah, we will do all the control ourselves.
Go ahead.
Professor Ting, Angela Swafford from Muy Interesante magazine. Can you compare, or would you compare, the AMS mission with the WMAP mission, which were, I think, probably the 2 biggest missions in terms of the fundamental questions? Are they comparable, and can you?
I do not know how to compare this. The WMAP founder, Dennis Wilkinson, who passed away, was my good friend at University of Michigan. Also, I've known him for a long time. Took him many years to build the WMAP. Unfortunately, he passed away quite early. Besides that, they are doing great work. I would not know how to compare this.
Mark Ratterman again with Talking Space. On the AMS02.org website, I saw a mention of galactic cosmic rays being an obstacle to manned interplanetary flight. How will AMS help to find a solution to that problem?
I do not read websites. And my family, particularly my son and my daughter, and read some website about me, said, "No, Daddy, this is not you." So I don't look at websites and don't read them. It is important to know a charged particle changes trajectory in a magnetic field. This was discovered 100 years ago. If you carry a man to space, when you leave the protection of Earth's atmosphere, Earth's magnetic field, you expose yourself to intense radiation. So if you go to Moon and Mars, this radiation in 3 years will kill you. And therefore, there's no, unless you have a protection, there's no need to come back. Because it takes 3 years to get there. Using a magnet system, a superconducting magnet system, is, in my opinion, the most effective way to bend the charged particles away. This is used repeatedly in all the laboratories in Europe, in the United States. When you have radiation particles, you use a magnet to bend the trajectories. So the development of a magnet system is extremely important. Indeed, some of my collaborators, Professor Boddystone is one of them, has studied this.
Seth Bornstein again at AP. For Dr. Ting, so on the 4th day you get moved to this from shuttle to station, and it automatically turns on. If you can go through the timeline of when you know that all the systems will be that are operating okay, how soon thereafter? 8 hours. And then when there's usually a shakeout period in scientific instruments, when do you start getting actual data? Or
when I say 8 hours, I mean 8 hours checkout time.
That's all? It only takes 8 hours of checkout time?
We have taken this detector, even though it's a very complicated detector, we have disassembled, assembled, disassembled, assembled, disassembled, assembled 3 times. I dare say we are quite familiar with what's going on inside.
So just to follow up on that, you'll be getting data 8-9 hours after you've moved. Given you're looking for very difficult to find data, I mean, is there something you're searching for also that will be showing you we're getting something far easier to find than antiheliums? And so will we, I mean, in Houston on day 7 or 8, could I come to you and you could tell me, yeah, we're finding this so far, it's nothing new, but it's something that's showing...
You're welcome to visit us.
I would love to visit you.
Yeah, welcome to visit us. And we are building a very large park and SOC in Geneva. And we made basically a carbon copy interior of what's on the park and SOC in Houston, because they look good on television. And I would say, for me, it will take quite some time before I open my mouth, say that we have found something.
Seth, on Flight Day 4, as part of the mission status briefing during the mission, Professor Ting and Mr. Sestili will be involved in the briefing with the flight directors to talk about the results that have been acquired. And we'll take a final question from this side of the room before we wrap up.
Scott Powers from the Orlando Sentinel. Dr. Ting, could you respond briefly to some of the critics out there, such as Professor Tarley at the University of Michigan, that have raised some strong concerns that you will not find either primordial antimatter or dark matter?
University of Michigan is where I went to school. Used to have a very good football team. In the last few years, the football team has gone to pot. Last year, they have changed the coach. I have no other answers.
All right. Thank you all very much. We'll wrap it up. I wanted to let you know that once again, at the conclusion of this briefing, you may ask some questions of the AMS collaborators here. Our next event on NASA television will be the rotating service structure retraction tonight when Space Shuttle Endeavour is revealed in the lights, and that will be at 7 p.m. Tomorrow morning, managers will meet to discuss whether they should go forward and tank the external tank. They'll meet at 5:45 in the morning. Our coverage of fueling would begin at 6:15 a.m., and our continuous coverage of launch will begin at 10:30 a.m., leading to liftoff of Endeavour at 3:47 p.m. tomorrow. You can keep up with all of our activities on the web at www.nasa.gov/shuttle. Thank you once again for coming.
So you can ask my collaborator.
Did you like the way it went?